In this lecture, we're going to see how we can use pointer arithmetic to navigate through data that is stored contiguously in memory in something that looks like an array. And what we're going to be using is by incrementing or decrementing our pointer depending on whether we want to move forward or backward. If you increment a pointer, it is going to move the pointer address by the size of the type pointed to by the pointer. So here we have an array of integers, and we know that scores, which is the name of this array, can be treated like a pointer that is pointing to the first element in this array. So what could happen if we incremented scores by 1? If we increment it by 1, we're not going to move forward by 1 byte. We're going to move forward by the amount equal to the size that an int takes up in memory. And let's visualize this a little bit. Here is how data would look in memory, a bunch of zeros and ones, and we have bits grouped into groups of 8. So each of these gray things here is a byte. And we have memory locations on the left and the actual data in that memory location to the right here in green. So if you look at our array here, we have 1 through 10, and this is the representation in memory here. So we have 1 through 10, and these are the memory locations on the left. So our array name should now be pointing to 1000 because that's the address of the first element in the array. And here in memory, we should have a representation of 1 in these 4 bytes here because an int is going to take up 4 bytes in memory, at least on my computer here. So what would happen if we incremented scores by 1? If we did something like scores plus plus. The compiler is going to first look at the type that we have in here. It's going to see that it's an int, and it's going to know that an int takes 4 bytes in memory. So 1 byte, 2 bytes, 3 bytes, 4 bytes. And it's going to say, if this guy is incrementing on this array, which contains an int, he probably wants to go to the next int. He doesn't want to go to the next byte. And what it's going to do is going to increment whatever location I am at by 4. So it's going to add 1, 2, 3, 4 bytes, and it's going to point to the next int in memory here. And that's going to be probably what we want because we just want to get the value in here, which is an integer. I really hope this makes sense. And this is the reason the compiler is going to do this transformation. You don't want to increment it, go to the next byte, because that wouldn't really make sense. You want to get the next int. So it's going to add the amount necessary to hit the next int, and that's going to be 4 bytes because an int is 4 bytes. So if you increment a pointer to int, the compiler is going to take you to the next int. It's not going to take you to the next byte. And this is hopefully making sense now. This is how we can do this in memory. We have a simple array called scores, and we have data from 11 all the way to 20. And we set up a pscore pointer, which we initialize with the name of the array. And we are doing this because we will be incrementing this pointer here, and we can't really increment on the array name because we can't change that. If we do that, we're going to get a compiler error. So we're going to go down incrementing pscore and watch it as it moves to the next ints and printing them out for us to see. You can also move by many ints forward by adding a specific number to the pointer that you have. So here you see that we have pscore. It is pointing to the first element in the array. And if we increment it by 4, it is going to point to 4 bytes away from the current location that we are at. And if we dereference that, we're going to get that printed out. So this is going to move forward by 4 times the size of an int in memory. And that's going to be exactly what we get. We can use this technique to print stuff from our array. We're going to reset our pointer to point to the first int in our array. And we're going to loop around like we've been doing all along. But inside, notice that we are using pointer arithmetic, and we are incrementing pscore by I to target the elements I integers away from the start of pscore. And this is how this is going to work. If we run this code, it is going to work. It is going to print our data, and it is going to be pretty cool. This is another technique you can use to print your data out. We can also use the array name in our statement here. Notice that this is working because we are just using the array name to get a value. We're not trying to modify the array name. So this is going to work, and we're going to see this in a minute when we hit Visual Studio Code. Here is another simple example showing you some of the cool things you can do with pointer arithmetic. Here we are trying to print the array in reverse order. We are starting by the size of the array, and we are decrementing, and we are using pointer arithmetic here to target the element that we want to print. And if you go through this, you're going to see that it is going to print each element in reverse order in the array that we have in scores. Here is another variant of the same thing here. We are assigning a value to p-score beforehand, and we are looping around doing p-score minus minus to move to the previous piece of data in our array, if I can say it like that. This is just another way to do things. You can even use array index notation, and this is the version that use the angle brackets notation to print things, and it is basically the same thing that we had in the previous slide. So you're just going to have to choose what you want to work with that is easier for whatever it is you are trying to do. Before we head over to Visual Studio Code and play with these things, I also want you to see that you can use pointer arithmetic to even modify stuff. So here we have the same array, and we can use angle brackets to put things in, but we can also use the pointer arithmetic technique to put data in, and it is going to work. You see here that we are dereferencing scores plus 1. So this is going to target the element at index 1 in the array, and it's basically equivalent to scores angle brackets 1 here. We can do the same using the p-score pointer here, and we're going to target the element at index 2, and it is equivalent to scores angle brackets 2 that we have here. And if we print the data, we're going to see these changes reflected in our array. Now that you know this, we're going to head over to Visual Studio Code and play with us. Here we are in our working directory. The current project is pointer arithmetic navigation. We're going to grab the template files pretty quick, and we're going to put them in. And we're going to open this in Visual Studio Code. And the first thing we want to see is that we can move forward in our array by just incrementing our pointer. Let's close this pane here so that we see the entire thing. Here we have our array. It is called scores. It has these elements inside. And we set up a pointer that is going to store the same address that the array name is storing, which is basically a pointer to this 11 in here. So if we go down, you see that we are incrementing to move the pointer forward, and it is going to be moving by size of int each time we increment it by 1. That's because an integer is going to take up 4 bytes in memory, so that's why we are having this behavior here. But this is pointer arithmetic in action. Okay, so some of you might be wondering, why are we incrementing p-score and not incrementing this scores pointer directly? Because an array name can really work like a pointer. Well, let's try and do that. We're going to try and do that here. I'm going to say scores, and we're going to try and increment it. Visual Studio Code is complaining already here. Let's bring up a terminal so that we can see what Visual Studio Code is saying. We're going to open our problems tab here, and it is saying expression must be a modifiable L value. So the problem here is that we are trying to change where the scores pointer is pointing. And scores is the name of an array. So we can't make the name of an array point to something else. This is really bad. You don't want to do this. That's why the compiler is stopping us from doing this, and we won't. Instead, we will go through another pointer that we set up ourselves, and the compiler is going to allow us to increment it and do stuff with it. Now you see that if we increment it, we're going to be pointing basically to the next element. So what the code down here is going to do, it's going to be printing each address it is at, and it's going to be printing the value inside. For the first time, it's going to print p-score. That's going to be the address of this 11 here. And we're going to dereference it and print it out, and we're going to print 11. After that, we're going to increment the pointer. So it's going to move by 4 bytes ahead, and it is going to point to the next integer that we have in memory. We're going to print that out. So that's going to print the address of the 12 here, And if we dereference, we're going to be getting the 12 here printed out. We are basically going to keep doing the same thing, and we will keep going until we hit the 20 here, I guess. That's what I had in mind when I set up this code. So let's try and run and see if we get that behavior. We're going to bring this up, and we're going to bring this to terminal, and we're going to build with GCC. The build is going to be good, and we are going to clear this and run rooster, and we're going to see that we have 11 all the way to 20, and we have different addresses in here. These are respective addresses of each element in this array here, and this is the code that is basically coming up with these things here. This is really cool. We can use pointer arithmetic to move forward in our array. We are going to comment this out because I have something else I want you to see. So we're going to comment all this code out here and go down and put our new code in place. And what we're going to show you is that you can increment by an explicit integer instead of incrementing by 1 like we did here. So what this is going to do is going to move us 4 nths ahead in memory. And we're going to be printing the element in our array at index 4. Let's go up and try to figure that out. The first index is 0, so 1, 2, 3, 4. We are going to print 15 because 15 is at index 4. So after we do the incrementation here and the reference, we should get the 15 printed out. Let's try, and before we run, notice that this is going to move us forward by 4 times the size of int. This is something you should keep in mind. So let's build with GCC, as we always do, and we are going to clear and run rooster. You see that we get scores at index 4 is 15, and this is exactly what we expect. And we can go through pointer arithmetic to do something like this. And again, pointer arithmetic here means that we are doing some kind of operation on the pointer to move ahead or backwards in our array. And in this case, we are moving forward by 4 times the size that an integer occupies in our memory. Okay, let's comment this out. And we are going to see that we can actually do what we did here inside the loop, which is going to be much easier. So we can go down and do that. And before we do that, we make sure that p-score is still pointing to the first element in the array. And we can loop around using the size of the array as our stopping condition. And we are going to use pointer arithmetic to target the element that we want to print. So what we're going to do is add the current iteration to p-score and dereference that. That's going to target each element. And this is really strikingly similar to the angle brackets notation that we would use to print something. And we should say something like scores I. And you see that by adding I, we basically have the same thing that we could do with the angle brackets notation here. Try to really wrap your brain around this. It is not hard to understand, and once you understand it, you're going to be using this all over the place. So let's try and build this. We're going to use GCC, and we're going to clear this out and run rooster, and you're going to see that we have just the values printed out. And this is just one way you can do this. But we can really also use the array name to do this, because this is not going to modify the array name. Let's show you an example. That's going to be better than me just talking about it. So we comment this out so that you can use this as a reference later. And we're going to go down and put in the code that we want to play with. It is basically the same thing like we had here, but notice that we are doing pointer arithmetic on the array name. We are taking the scores pointer and adding stuff to it. And again, this is going to work because we are just using this in an expression. We're not trying to modify the scores pointer, which happens to be the name of an array here. If we try to change it, we would get a compiler error like we did here, but we are not trying to change it here. We are just grabbing the value in it and adding I to that. And if we use this code and compile it, let's do that with GCC like we always do. The build is going to go through, and if we clear and run rooster, you're going to see that this is going to work. So if it makes sense to use a pointer, use that. If it makes sense to use the array name directly, go ahead and use it. It is going to work. The next thing I want you to see is a simple example that is going to show you that we can print things in reverse order using pointer arithmetic. Let's put the code in here because I don't want to type all this. So we're going to print the elements in reverse order. You see that we are starting at the size of the array and we are doing the decrementation here. But the meat of this is the pointer arithmetic we are doing here. Okay, so we are going to take the scores and add I and -1 to target the element in the correct boundaries of this array. If you try to go through this, you're going to see that it is going to start at the last element in the array. So it's going to go to 20. The first iteration is going to be the 20 here printed out. And we're going to be decrementing with pointer arithmetic until we hit 11. And we're going to print it and end. Go down here and look at this code a couple of times and you're going to understand it. I don't really want to go through this because we have explained loops. It would be a waste of time here. So we're going to build this. And we're going to see the build result, which is successful. We're going to clear and we're going to run Rooster, and you're going to see that we have 20, 19, all the way to 11. I am going to comment this out and show you another version of doing the same thing. So we're going to go down and put that in place. And here we are setting up p-score to be the pointer to the last element in our array. So when this statement here runs, p-score is going to be pointing to the 20 here. Okay, so let's go down and try to really understand this. We are going to take scores. We're going to add the size of scores and we're going to -1. The size of scores is 10 because we have 10 elements. So if we take scores and add 10, we're going to go, scores is pointing to the first element here. So we add 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If we go 10, we're going to be pointing to one element past the legal boundaries of the array. That's why we need to do another -1 to come back to the 20 here. Okay, so let's go down and look at that. So p-score is going to be pointing to 20. So we're going to start looping around, dereferencing p-score, printing out the value pointed to, and then decrementing it so that the next iteration is going to be one element backwards. This is really what we are doing here. And if we build and run this, we're going to get the same result. So let's do that. We are going to clear this and run Rooster. You're going to see that we have our things printed out here. So these are just a few examples to show you how pointer arithmetic can really come in handy if you are manipulating data that is stored contiguously in memory, just like this array of events here. Okay, so here we have been using pointer arithmetic, but I don't want you to think that it is the only technique to do these things. If you want, you can also use the angle brackets notation with your arrays and do pointer arithmetic-like operations. So here we have the code that is going to print the same elements in reverse order, but notice that we are using angle brackets notation here, and it is going to work. So go through this, you're going to see that it is going to target all the elements from 20 to 11, and we're going to get these things printed out. So we can try and build this now. We're going to build with GCC. The build is going to go through, we can clear and run Rooster, and we're going to get the same things printed out here. Let's comment this out and show you one last thing before I let you go. And that's going to be that you can go through pointer arithmetic to modify your array. I am going to go down here and put this in. Let's bring this down a little bit so that we see the entire thing. We are making sure that p-score is pointing to the first element in the array. And we are using angle brackets on this line here. This is nothing new, but we can also use pointer arithmetic to target the data that we want to change in the array. For example, here we are targeting the element at index 1 with pointer arithmetic. This is going to be equivalent to this notation we have here. And down here you see that we target the element at index 2, but now we are going through the p-score pointer. So we can either use the array name or a separate pointer, and it is going to work equally well. If we print the elements here, you're going to see that the first, second, and third elements are going to change to 31, 32, and 33. And let's try and build to prove that. We're going to use GCC as always. and we're going to clear. And if we run rooster, you see that we have 31, 32, 33, and we have a 14 like we just had before. This is really all I had to share in this lecture. Pointer arithmetic can be really confusing for beginners, but I tried to break this into little examples that show you some of the cool things you can do with this way of doing things. We are going to stop here in this lecture. In the next one, we're going to see that we can also use pointer arithmetic to compute the distance between elements in an array like this. Go ahead and finish up here and meet me there.